Hello everyone. In this lecture, we are going to talk about information bias. Information bias is a bias that creeps into our epidemiological study because of problems in how we measure the different variables and how we classify certain subjects into certain groups. So this is broadly information bias. Today, we are going to see what is the definition of information bias and what are the different sources of such information bias. So, formally, information bias is defined as the distortion in the estimate of the effect due to measurement error or misclassification of study participants on one or more variables. Now, what does that mean in real life? When you are measuring something in a particular research study, let us say you are measuring the blood pressure of a group of people. If you use a faulty instrument that has, say, a bias of 10 mm, which means all participants who are measured have 10 mm of blood pressure more compared to the actual value. So that is called an error in measurement. This is not only applicable to instruments like blood pressure or SpO2, oxygen saturation, or say some other biochemical parameter. It also may refer to things which are obtained by asking questions. So for example, if I say I'm going to ask the smoking status of a patient who has come into the research study like so. Do you smoke? So this is a very simple way of asking a very complicated question. The participant may say yes, he may say no. The participant may say used to smoke but now I have quit. So there are hundreds of variations in which you can ask this particular question. And the way in which we ask the question determines the accuracy of the answer to that question. So this is called error due to measurement. The way in which we measure variables in a study is error prone. The second part of the definition of information bias deals with misclassification. So what does misclassification mean? Misclassification means you have wrongly assigned a participant to a particular group to which he or she does not belong to. Now let us take two groups, obese and non-obese. A participant comes to you, you make a measurement of their obesity. The person is actually obese, but you put them under non-obese. So this is called misclassification. Let's say you are going to study hypertension. You measure the blood pressure of a person and you have to classify that person into either hypertensive or non-hypertensive. But due to some error in measurement or some error in your classification, you wrongly put the participant under one group when in fact he is a member of the other group. So there are so many examples of misclassification, and these are the two different components of the definition of information bias. So let me remind you once more, information bias is the distortion in the measurement or distortion in the result that we are getting in a particular study due to measurement error, that is the way in which we measure, or misclassification of the participants. So these are the two broad concepts of information bias. Now let us move on to possible sources of information bias. So, as I said previously, epidemiological data might include either measurements or classifications. Measurements, we generally talk about continuous variables like systolic BP, urine output, serum creatinine, hemoglobin levels. So, these are measurements, and depending upon the instrument, there may be errors in measurement. Then, there is something known as classification. So, classification means we are dividing a participant into a case or a non-case, hypertensive or non-hypertensive, diabetic or non-diabetic, male or female. So when you are trying to classify participants into one or two groups, there might be some errors in how you classify them. So these are broadly the two areas that we are concerned with when we are talking about information bias. Now let us see what are the possible sources of such error. So there are 6 possible reasons why information bias can occur. Number 1, instrumentation. I told you in the beginning of the lecture, if you use a faulty instrument, it can lead to information bias. The second source is respondents. The way in which respondents give answers to your questions can cause measurement error. Data collectors. How you train the data collectors can be a source of error. Data managers. Those people who are involved in collecting, collating, and handling the data. Data analysts. So these are the people who analyze the data after the data has been entered into a particular software. Then finally, data interpreters. Those who sit and look at the results and make certain interpretations about the data that has come in. So these are the possible sources of information bias that we are going to look one by one into. Instrumentation error, as I said, occurs due to a lack of calibration of the study instrument. I gave you a simple example of a BP measurement monitor, right? A sphygmomanometer which is wrongly calibrated. It could be a weighing machine which is wrongly calibrated. It could be a HemoQ machine which is wrongly calibrated. It could be a study tool which is not necessarily instrument. For example, let's say you are using a scale for the measurement of some abstract phenomena. Let's say you are using the quality of life index to measure the quality of life of a particular disease condition. So, if your instruments are not calibrated, if they are not valid, if they are not reliable, they can lead to information bias in the form of measurement errors. So, instrumentation is, I think it is pretty straightforward. If the instrument which you are using to measure a particular variable or a particular data point, if that instrument is error prone or if it is biased, then your results will also be biased, as straightforward as that. Now, let us come to respondents. Respondents are study participants who give answers to your questions. There are several processes that are happening in sequence or sometimes parallelly inside the mind of the respondent before he or she gives you a response. And if we don't understand these processes, the questions that we frame in our survey are likely to be less reliable and less valid. So, most of the times, the problem comes due to inability to understand the question from the respondent side. The respondent doesn't understand your question simply, or the respondent understands the question, but he or she is not able to recall. They know that the information is somewhere there in their memory, but unfortunately, at that particular time in point, they are unable to recall from memory. Even if they sometimes recall, they might not be able to articulate it in a way that the interviewer is able to understand. These are problems with cognition and responding. Sometimes the participant may be unwilling to disclose certain information like some sensitive data that you are asking. For example, if you are asking about the income of a study participant, he or she may not be very comfortable disclosing the income to the actual amount. He or she may give you a answer which is common or which does not arouse any suspicion. And sometimes when you're asking about personal behaviors like smoking, alcohol, drug abuse, sexual orientation, these are all things that are not commonly discussed or commonly or socially desirable habits in a person. So when you're asking about such personal behaviors, again, the participant may tell you an answer which you are expecting or which is socially desirable rather than telling the truth. So these are some of the problems that the respondents might have in responding to your question, and that may lead to errors in measurement. So just to give you an idea of the cognitive process that goes on inside the respondent when you ask a question is, these are the cognitive processes. The participant has to first interpret the question that has been asked. Then the participant has to recall what has been asked. Then the participant has to make a judgment about the information that they have recalled. Then they have to format a response that they will give out to you. And then they will edit the response before giving it to you. These are the steps in the chain of the cognitive process before the respondent gives you an answer. So, problems can occur in each of these steps. And when you are designing a survey instrument, a questionnaire, you have to think about all these cognitive processes that are going on inside the mind of the respondent. So, the way in which you frame your question, the way in which you ask your question should not allow errors to creep in any of these cognitive processes. For example, let me ask you a question. Did you perform any physical activity during the past month? Let's say this is a survey question. Now, what are you thinking? What does he mean by physical activity? Does only walking, running, jogging, and hitting the gym mean physical activity? Or being simply at home, dusting the rooms, washing utensils, shifting things from one room to the other, and in general, the day-to-day activities also qualify for physical activity? So, and what does he mean by past month? Does he mean the month that was before this month, or does he mean the 30 days prior to this particular day? So, different people might interpret this question in different ways, and therefore, errors creep in because each one understands the question differently. So, this is just an example to make you think that a simple question can lead to errors due to the problems in cognitive process for that might differ from person to person. How to overcome this particular problem of recalling and problems in cognition? So there are several ways in which the interviewer can help the participant or can help the respondent in trying to give a piece of information that is both reliable as well as valid. They can give certain probes to help the respondent. Maybe you can connect it to some known dates like birthdays, important festival dates. If you are asking for information on when a particular thing happened. So if you are asking for information that requires a longer recall, let's say beyond 1 year or at birth or during your childhood, those are things which are more prone to error as compared to things which are more recent, let's say within a year, within 6 months, or within the last month. So when you are framing the question, try to think of this cognition process that will go on in the mind of the respondent when the question is asked of him. Another way of designing good questions is to conduct a qualitative pilot. That is, you gather a bunch of prospective respondents and you ask them to go through the questions that you would ask in your survey. So question by question, these people can discuss what they have understood, what are the problems in that question, what parts of the question are unclear, and so on and so forth. And that helps you to design a question which is much better than your initial question. The next source comes from the data collector. So these are people who are going to ask the questions from the respondents. If we do not adequately train these data collectors, there might be variations in how each of them is asking questions to different sets of respondents. The data collector might ask questions which are unclear or ambiguous to the respondent. The data collector might not have a neutral demeanor or a neutral tone when asking certain types of questions. For example, if the data collector conveys in any way through his body language or tone that a particular behavior is not healthy, and if that question is perceived by the participant or the respondent as such, then he or she is more likely to give an answer which the data collector will feel happy about. So, if the data collector is not neutral about the questions that he or she is asking, it can lead to errors in how the participant is responding. If there is a written protocol for a particular study, then the data collectors should be well versed with the protocol. And if they are not following the protocol with adequate care, then this can also result in information bias. Sometimes when we are transcribing data from one source, let's say a questionnaire which is in English, and the data collector is translating that English question into some local language question, and there is some error happening during this translation, it can also cause errors in how the participant responds. So inaccurate transcription can also be a problem. And finally, it is much easier to collect data sitting in your home watching TV, manufacturing data, right? So fraud can also be a major source of error. It has been shown that previously data collectors are known to involve in such practices. So a mechanism for monitoring supervision has to be in place, and a percentage of the interviews or a percentage of the households have to be rechecked for quality assurance. Another example of a question that can lead to major errors in responding is asking a loaded question. So, what is a loaded question? A loaded question is that which has a false, disputed, or question begging presupposition. For example, if I ask you, have you stopped smoking? You can give two answers. You can tell me yes or no. If you say yes, I am forcing you to say that you were smoking, but you have stopped now. If you say no, I will assume that you are still smoking, but you may not have smoked at all. That is not captured in this question. So I am presupposing that you are a smoker, and therefore I am asking the question, have you stopped smoking? So these are the kinds of questions which are ambiguous also, and the respondent is cornered into saying one of two things which may not actually reflect the truth. There are other examples of loaded questions as well. Coming to how data managers or the data management can lead to measurement error. When data is transcribed from one source to another, let's say when data entry is happening, it can lead to the person who is entering the data can enter the data wrongly because of transcription errors. Misreading. Certain data points that have come to the data manager might be misread as something else and entered as wrong information. Miscoding. So this happens when you are entering codes rather than the actual answer that has been given. So for example, if you are giving a code of 1 to yes and 0 to no, and if the person who is managing the data or if the person who is entering the data understands it wrongly, say he thinks 0 is yes and 1 is no, then the entire thing goes wrong. This is a major source of measurement error. And finally, programming errors. When data managers write computer programs to manage databases, they can also introduce certain errors by not taking adequate care. Then come the data analysts. So the data analyst should be well versed with the questionnaire, the coding scheme, and how the data has been stored or managed. If the data analyst does not have a proper idea about how the data has been managed, he or she is likely to conduct an analysis which is not proper. And again, variable coding and programming errors are also possible when data analysts try to do the statistical analysis. One example which I gave you is coding yes as 0 and no as 1 when in fact it was the other way around. And sometimes when you are writing programs for data analysis, let's say you are interested in calculating the estimated GFR and there is a equation called the CKD EPI equation which requires you to enter some data and calculate the eGFR by some equation. So if the programmer understands the equation wrongly, he or she can lead to wrong calculation of the eGFR. And finally come the data interpreters. After the analysis has been completed and when the results are in front of the research team who is going to interpret the study results, if they are not paying attention or if they have inadequate understanding of what has been measured and how the relations have been studied, it can also lead to measurement error. Say for example, in a cohort study, the measure of association was given as relative risk. If the data interpreters are not aware of what relative risk means and if they are not aware of what is the exposure variable and what is the outcome variable and which was used as the control group and which was used as the group for which the measure has been calculated, this can lead to wrongful interpretations of the data which has been analyzed properly. So till now we have seen that during the process of data collection, during the process of data management, during data analysis and up to the level of interpretation, errors can creep in at any level and all these together contribute to measurement error. So how do researchers deal with measurement error? There are several ways and there are several techniques by which we can reduce these sources of measurement error. So when we are defining variables, when we are defining study questions, we try to be as precise as possible and we operationally define wherever there is likely to be ambiguity. So this will go into the standard operating procedures or SOPs that have been developed for the project. It can be also a question by question guide which the data collector carries along with them so that they can refer to this question by question guide and see how to ask a particular question, and if there are any doubts they can refer to this guide. Detailed measurement protocols. So these are written instructions on how to carry out a particular measurement. Let's say you want to measure the height of a person in a project. So how do you do that? You can simply ask the person, what is your height? That is one way. You can ask the person to stand in front of a stadiometer and simply casually you can take their height, or you can follow a written defined protocol. You have to remove your footwear, you have to stand straight, your occiput, your buttocks and your heel have to touch the back of the stadiometer. You have to look straight and then only measure height. So you can be as lax as possible or you can be as strict as possible. And that depends upon how accurate or how precise a measurement you want. Same thing holds for asking questions as well, not only using instruments. Repeated measurements on key variables. So if a particular variable is very, very important, that you don't want to go wrong on this particular variable, then we can increase our confidence on that particular variable by doing repeated measurements or by asking for the same information in different ways. Then comes training, certification, and recertification. So what does this mean? So if there are, say, 5 or 10 or 15 data collectors in your research project, you train them. You train them adequately and you certify them as being trained for data collection. And you can send them into the field, they will be collecting data. If the project is going on for an extended duration of time, let's say 5 years or 3 years, you can call them at the end of every year or at the end of 6 months and train them again and recertify them. So by this way, you are not allowing any room or any chance for the data collectors forgetting the things that they have been trained on. Then comes data audits. So data audits are a review of how the interviewers are conducting the interviews and how the data managers are capturing the data, entering the data and managing the data. So you take a random sample of the respondents or you take a random sample of the forms and you verify the information again. So you can go to the same households that the interviews have gone and you ask the same respondent to fill the questionnaire again. And you see what is the difference. If there is a major difference between what the respondent has answered to you and what the respondent had answered to the previous data collector, then it means there is some problem going on. You can also review how the data management is being done. So you can say take 5% or 10% of the forms that have been entered and re-enter them and see what problems are arising. If there is no problem, then it's good to go. But if there are major errors or major deviations between what has been entered new and what has been entered previously, then we need to review the process again. Data cleaning. So there are different ways of cleaning data and each person or each data analyst has his or her own way of cleaning the data. So you can visualize how clean the data is by using computer applications these days. And one final point that will help us reduce error is to rerun all of the analysis prior to preparing a report or a manuscript or sending out to publication. So there might be different steps, there might be different analysts who have come and gone, there might be different thought processes going on during the analysis phase. And once everything is finalized and your tables and your figures are all ready, you rerun the analysis one more time to see that everything is matching so that you are absolutely sure that there is no error anywhere. So these are some of the ways in which we can reduce the measurement error.
Thank you.